This video is going to cover Unit 25, Section 1. We're going to talk about some definitions of things involving a circle. Okay, the first thing is the circumference. Circumference is the distance all the way around a circle from one point to the other. So from right here, all the way around the circle to here, that is the circumference. So from here all the way around back to here. So from E to E, that is the circumference. A chord is a segment that goes from one edge of the circle to the other edge of the circle. So AB is a chord. Now the diameter is also a chord. So CD is a diameter because it goes from one edge of the circle to the other edge of the circle. So that is a chord. However, it's a special chord because it goes through the center of the circle. So center point O. So a diameter is a chord that goes through the center. Now a radius goes from the center out to the edge. So from O to E, that is a radius. Also from O to D and from O to C. Those are radius as well. Now arcs. An arc is a distance on the circumference. So if I say arc AB, I'm talking about going from A to B, but not across the chord, on the circumference of the circle. So if I was able to take a string or something and stretch it around that and then hold and then stretch it straight, I could measure the distance of that arc right there. So an arc is on the circumference. Now there's a couple of different ways we can look at an arc. If I said, for example, arc AB, and I wrote it like this, and this curved on the top means arc. That would mean the distance from here to here, but around the circumference. Or does it? What if I'm talking about the distance from here to here, but now I'm thinking this way around the circle? Okay? That would also be arc AB. So, we have a problem. We have to solve it. We have two arcs that go from A to B. One is the minor arc or the small arc. The other one is the major arc or the bigger arc. So we have to include another letter. So I'll go A, B, and that's an arc. However, I have to put another one of these letters on that are on the circumference. It doesn't even matter which one. Let's put a C. Okay, so that's telling me, because that C is in the middle, that tells me that I'm going from A and I'm going in the direction of C, and I'm going to stop at B. Now I could have labeled it A, D, B. That still tells me that I'm going this direction around the circle. So you got a minor arc and you've got a major arc. Okay, now let's look at this one. Okay, we're talking about tangent lines and secant lines. A tangent line would be something like line CD. A tangent line is a line that runs and it touches the circle only on the circumference, only on the edge. So this line is a tangent line, so therefore it will touch the circle only one point, which is point P right here. A secant line is a line that goes through the circle and it touches it at 2 points, here and here. So this line right here, EF, is a secant line. Tangent line, secant line. And this point right here, P, would be the point of tangency. Tangency. Okay, over here on this circle, we have a segment and a sector. Okay? A segment is formed by a chord, and then the area, a segment and a sector are both areas. So we have this area right here from this chord all the way to the edge. That is this segment. This sector is the area within this angle here. The angle is in the center, starts in the center. So the vertex is at the center, and I draw one radius out to the edge and another one out to the edge, and that area within there is a sector. Now, a segment can be part of a sector. For example, if I draw a line, a chord from E to F, I don't know if it's going to show up very well in there, but if I draw it over there, then there's a segment down here as well. Or I can come up here and I can just draw a line from there to there. Now, this area here is the sector, and this area right here is the segment. Okay? Continuing with our definitions down here to this circle, we have different kinds of angles within the circle itself. We have an angle here, which we would call a central angle. Now that is an angle very much like this sector right here, actually exactly like this. This angle right here, E to F, is a central angle. So this angle right here is a central angle. This angle right here, it's inside of the circle. However, the vertex is on the edge. We call this an inscribed angle. An inscribed angle is one in which the rays or the edges of the angle are chords. A central angle is one in which the edges of the angle are radiuses. All of these definitions are on page 612 and 613. Okay, let's see what we have here. Power up. Okay, looking at page 615. Okay, let's see what we have here. Number 10, refer to figure 2511. Write the word that identifies each of the following. Angle 1. Angle 1 would be a central angle. Angle 2 would be an inscribed angle. Arc CE would be a minor arc, or just an arc CE. And then DCE, I would look at that, and there's nothing above it, so I'm going to call that the chord. And CD, I'm also going to call that a chord because it doesn't have the arc above it. And let's see here. Number 8 on that same page. Yep, I'm going backwards. Write the word that identifies each of the following. Okay, so A is line H. Almost said R. That's HK. That is a secant line. B, C, or G to F, we'll call that a minor arc because there's no letter between them. C is G to F. Now there's no arc symbol above it, so I'm talking about the line. That would be a chord. D, it says line LM. And I'm going to make the assumption that that is a tangent line, and point P, which is E, point P is the tangent point. Then F, we've got arc GPF. So I'll call that one the major arc that starts at G and goes around to the right all the way around the circumference until it meets point F and going through point P. That makes it a major arc.